Hi, welcome to another session of physics. Today we'll see a continuation of these forces series. We have seen examples in inclined planes and also suspended objects. The third most common example would be elevator questions. All right. Now in elevator also I'll divide it into two sections. One is about elevator including the person or the people inside, and second situation would be just the person inside the elevator, how his contact force or the weight changes and so on. Right. So the first one, elevator as a whole, would be simple for you to understand. I have told you before, you need to first consider or identify which way the acceleration is going to be. Alright, now the elevator as a whole, here I've just drawn a couple of people here. Now we are not interested in what's happening inside the lift. We are actually looking at the lift as a whole, as an object. What are the forces acting on it would be. Of course, it will be connected with the cable, right, for it to move up and down, and lift's weight will be acting down. So you'll have two forces, the tension in the cable acting up and the weight that is acting down. Now you have to think about these two forces, how they change based on the movement of the lift. Now say again, if it is in equilibrium, constant speed, or if it is at rest, then W will be equal to T. So this is equilibrium state. So that will be easy. If it's constant speed, or if the lift is stationary, then W equals the tension. Now what we have to pay attention to is when it is accelerating or decelerating. Now if it is accelerating up, in the accelerating direction is where the force is greater. So if it is accelerating up, then T will be greater than W. There is a resultant force. So you subtract T minus W will be equal to your resultant force. This is for acceleration in the upward direction, right? Now this we can equate to ma, mass into acceleration. So T minus W will be equal to mass into acceleration. So the first thing is you have to identify which direction it is accelerating. Then that force minus the opposing force will be equal to resultant force, and equate that to m into a. Now if it is accelerating down, then how will the equation change? If it is accelerating downwards, then the downward force is greater than the upward force. So W minus T will be equal to mass into acceleration. Right? Do you get it? Here it's the same. Here it is accelerating up, so the tension will be greater than W. Here it is accelerating down, so weight is greater than tension, that will be equal to mass into acceleration. I hope it's clear. So don't think there is a standard equation for solving. No, you will have to modify the equation based on the direction of movement plus whether it's accelerating or moving at constant speed. Alright. Say if it is decelerating down, how will the situation change? If it is decelerating down, which means is W greater? No, the opposing force is greater. So in that case also you will have T minus W equals ma. Got it? Similarly here, if it is, here we have said acceleration down, if it is decelerating down, then again tension will be greater than W, so you'll get T minus W equal to ma. I hope this is clear. Now looking at the person inside the lift. Now what are the forces acting on the person? You'll have weight acting, so if you take this point as a dot, W will be acting downwards, and you will have the contact force acting upwards. Now will that be the same throughout? Now you have to remember weight is actually a measure of the contact force acting on the person. Okay. Like weightlessness, we say you will feel weight, there is a chance for you to feel weightless inside a lift if the contact force and the weight, like if you're just about to get lifted off the floor, you will feel lighter. Similarly, when you're going down at a greater speed, then you will feel weightless, but when you're going up with a, if it is accelerating at a faster rate, you will feel heavier and so on. That's because of the change in the contact force. which will be read by, or which will be equal to W, or that will be read by a scale inside a lift. Okay. So sometimes they modify the question, or situation is the same, but the question will be what will be the weighing scale's reading when the lift is accelerating upwards or it is accelerating downwards. It's nothing but you're actually calculating the resultant force acting on you, or the contact force acting on you, which will be equal to the reading on a scale. Alright. Now, when the lift is accelerating up, so what can I say about the contact force on you? The contact force will be greater than W, correct? So, contact force minus W will be equal to M into A. So, if I change the subject of the formula, so Cf minus W is equal to Ma. So, contact force will be equal to W plus Ma. Correct? W plus Ma. That means the contact force that you feel from the ground will be your weight plus an additional term of Ma. That's the reason when you're accelerating up, you feel heavier, as though you are being pulled up and so on, right? So if you frame the equation correctly, from the equation you'll be able to answer even theory questions as well. What if you are accelerating down? Then W is greater than the contact force. So that will be equal to the resultant force Ma, right? So contact force will be equal to W minus Ma will be equal to contact force. So you notice that this term actually will be removed from the W. The resultant force, when it is subtracted from W, that is the contact force that you feel. That's the reason when it is accelerating down, we feel lighter. So when will the contact force be equal to 0? When this acceleration or the resultant force, when it equals W, you will feel weightless. You're almost there. Now, if this acceleration is greater than your weight, then you will be lifted off from the lift. So the acceleration of the lift is very important. So when you have situations here, as I said, you try to figure out what is the resultant force, what are the first two forces acting on the object, two or more forces, and how is it acting, which one is greater than the other one, whether it's accelerating or decelerating. And then if you combine, you'll be able to come to a conclusion about the resultant force and the contact force and so on. And I hope you'll be able to answer correctly. Now in the next session, we'll see a few examples related to these concepts that will give you a better understanding. See you. Bye.